Let's solve a trig equation using a double angle identity. And we're going to solve the equation 2 cosine squared theta minus 2 sine squared theta plus 1 equals 0. And there is no double angle. You'll see that we just have a cosine squared and a sine squared. And then you look at this and go, but to solve a trig equation, I need just one trig function. Ugh. And so then you start thinking, well, how can I manipulate this equation? You see sine squared and cosine squared and think, ooh, maybe it's Pythagorean identity. No, Pythagorean identity has sine squared plus cosine squared, and we have minus. So that doesn't work. You keep going, and then you notice that the cosine of 2 theta equals cosine squared theta minus sine squared theta. And we have hit a jackpot because we have cosine squared theta minus sine squared theta. The only problem, we have these 2's, but we know how to do this. We have algebraic skills. We can, first off, well, I've got to move this out of the way. I can't factor out a 2 if I have something. So just to be mathematically correct, I'm going to go ahead and move that to the other side. You can do it without, but I'm not trying to confuse anybody. So once I move that 2 out of the way, I can focus on the left side and say on the left side, I'm going to factor out a 2. So if I factor out a 2, I get cosine squared theta minus sine squared theta. Okay? So doing that allows me to say, well, if I have the same, then I can substitute. So I can take this cosine of 2 theta and substitute it in. So my equation will become 2 cosine of 2 theta equals -1. Well, great. Now I have just one trig function, and I can isolate it. I'm halfway there. I just need to divide both sides by 2, and I get the cosine of 2 theta equals -1/2. Okay, well, now we've got to do some thinking. So I have the cosine of 2 theta equals -1/2. First, we've got to think about cosine in general. So we know that the cosine of theta is on the interval of 0 to 360 degrees, because we are working in degrees on this. And that's great and all, but we don't have cosine of theta. We have the cosine of 2 theta, which means we are multiplying everything by 2. Well, 360 times 2 is 720. So that means for this problem, I am working on basically 2 rotations of my coordinate plane, right? My unit circle times 2. So when I look at this, now I go over and say, okay, I have cosine and it's negative. Where is cosine negative? Well, quadrants 2 and quadrants 3. Great. So where is cosine -1/2? That's our question, right? You could also, if you need to, you could use your calculator, inverse cosine of -1/2. We don't need to do that because we know that the cosine is -1/2 at 120 degrees and at 240 degrees. Think about your coordinate plane. We've got 120 and we've got 240, right? So this one's 120, this one is 240. But that's only in one rotation. Remember, we're going to 720 because of this. So for my 120, I'm going to have to add 360, and I get 480 degrees. And then for 240, I add 360, and I get 600. So those are my degree measurements for 2 theta. But friends, if we're solving an equation, we don't solve for 2 theta, we solve for theta. Which means to get that, we need to divide everything by 2. So my values of theta are going to be 60, 120 degrees, 240 degrees, and 300 degrees. There are my solutions for theta, for this particular equation. Remember, our initial equation was 2 cosine squared theta minus 2 sine squared theta plus 1 equals 0. And we have 4 solutions. And you'll notice our 4 solutions do fall in the interval 0 to 2 pi, or excuse me, 0 to 360 degrees. So that fits the first part of our equation, or the first part of our question was on the interval 0 to 360 degrees. But then it also says for all solutions. All right, so let's think about this. I know, let's get ourselves a coordinate plane and our four solutions. Our four solutions are 60, 120, 240, and 300. Yes, that's exactly what they look like. So I am taking, if I take 60 and I add 180, I get to 240. If I add another 180, I get back to 60, right? So if I'm thinking for all solutions, I can say, okay, that means I can take 60 degrees and I can add 180 degrees times n, because every time I add 180, I'm back to an angle that exists. That is a true statement. Now, the other one is if I start at 120 and I add 180, I get to my 300. And then if I add 180, I get back over to where I was. And again, every time I add 180, I'm to one of my solutions. So then I could also say I'm going to take 120 degrees and add 180 n. And again, n is any integer. And if you were thinking, well, I would take 60 degrees plus 360 n, and I would take 120 degrees plus 360 degrees n, and I would take 240 degrees plus 360 degrees n, and 300 degrees plus 360 degree n. That's not wrong. That is absolutely not wrong, because you're taking each angle and you do a full rotation, 360 degrees, and you get back there. You're just writing it 4 times. And here we can write it more succinctly, because every time you do the 180, you get to a correct answer. So technically these are both correct, but if you're trying to write your answer as simplified as possible, you want to go with the idea that every 180 degrees I am at a correct solution.